Hello. Hello. Can you hear me?
Yes, I
Yes, I
can
can
hear
hear
you.
you.
Okay. So how are you?
I'm
I'm
fine.
fine.
Okay. Okay. Thank you. Okay. Okay. So basically today I will try to discuss about that flood susceptibility mapping,
Okay.
how we can
Okay.
easily use using Google Earth Engine platform and find out the flood hazard risks area. This is the high risk, low risk, moderate, medium. So these type of things how we can easily do using Google Earth Engine platform very quickly and also very efficiently we can do. So let's go about that. So just I simply share my screen and try to show you that things. So can you see my screen? Is it visible?
Yes.
Okay.
Yeah, yeah.
Okay. So first of all, I try to discuss about the some theory part about that, and then try to discuss about this code. Okay. So just I simply open my slide. Okay. So basically, flood susceptibility, it depends different types of flood factor. One kind of factor, it's called the topographic witness index. Okay, so it's the one factor for flood. Also, elevation. So it's a major factor for the flood. Land use, land cover classification. It's the another factor for flood. Also, you can see the slope. Okay, slope is another factor for flood. Also, precipitation. Okay, it also major factor for the flood. Also, you can take the drainage density. It also major factor for that flood. Also, you can see about that. Okay, just I simply open my paper. It also better. Just to open this. Yeah, just to simply open these things in the doc file. Okay. So basically, here I already write this type of flood susceptibility factor. TWI, then elevation, then land use land cover, then slope, precipitation, drainage density, NDVI, distance from river, distance from road, and then soil type. So basically, it is the major factor for flood. And now, how it will be contribute to the flood. So basically, topographic index here you can see TWI. So mainly TWI, it's a topographic index, and this topographic index is also known as the compound topographic index. Mainly, it's the commonly used to quantify topographic control on hydrological process. Okay, basically, it's to quantify the topographic control on hydrological process. And when you get the low value, suppose you can get the low value, suppose minus 22, minus 14, it's very low value. Then you can see the low, very low, low, moderate, high, very high. In this time, we just make the some class. Suppose minus 20 to minus 14, it's very low. Minus 13 to minus 6.4, it's very low. Low. Then minus 6.3 to 0.3, it's the moderate. 0.3 to 3.6, it's the high. 3.7 to 14, it's very high. Okay, so basically when I can get the very low value, it's indicating the
Okay. This
yes,
kind of classification, where we get
yes,
this kind of 20,
yeah. In this
14.
time we have to generate this TWI for our study area. Then we can make the class total 5 class we generate.
Okay. We will download. We will
Yes,
download this TWI,
yeah,
right?
we have to generate. So basically
Okay.
we can easily
Ah,
generate
okay.
using the Google Earth Engine platform and also make the class.
Mm.
And suppose when I can get this type of low value, it's indicating the very low susceptibility.
Okay.
Then low,
Okay.
moderate, high, and some elevation. Elevation mainly where I can get the low elevation. Suppose 0 meter elevation. It's a very high susceptibility for flood. Okay. Then when I can get the high elevation, you can see it's very low. Okay, so in this time this elevation we also make the total 5 class. And when I can get the low elevation, it's identify the very high susceptibility for flood. And when I can get the high elevation, it's identify the very low susceptibility of flood. And also for land use land
Yeah.
cover, you can see land use land cover. Mainly water body. Water body is the high susceptibility of flood. Suppose river, then suppose canal or any lake where is available for water. Okay, so this water body is high susceptibility for the flood. Then barren land high, agriculture moderate, settlement low, and vegetation very low. Also, you can see the slope. You can see when I can get the very low slope, suppose less than 0.93, it's the very high susceptibility of the flood. Very low slope, very high. And when I can get the very high slope, it is a very low susceptibility. So that's why we also consider the total 5 class of the slope. And from here, we can easily make the slope class, and we can identify when I can get the very low slope, it's identify very high flood susceptibility. When I can get the very high slope, it's identify about that very low susceptibility. Also, to for the precipitation. Okay, suppose I make the total 5 class precipitation value, and here I find out the very low precipitation, it's identify very low susceptibility. Where I can get the high precipitation value, it's identify very high susceptibility. Also drainage density. Okay. Also NDVI or distance from river. Mainly distance from river. It's
So
we can
why for precipitation we don't have the class?
okay. So in this time I will not do that because I not complete this full project yet.
Oh,
It also working. Okay. So but same process.
okay.
Suppose when I do for this work for your study area, we have to make the some precipitation class, total 5 class. Suppose low precipitation, identify about the very low, then and high precipitation value, identify about the very high susceptibility of the flood. And also for the drainage density, NDVI, or distance from river, distance from road, or soil type. Mainly distance from river, when I can get the near to the river distance, it identify the high flood susceptibility. And far from the river distance is identify the low susceptibility of the flood. So we are also create this type of distance from river, distance from okay. So in it's one is the distance from road, distance from road, and distance from river, then soil type. So we do and then make the class. Okay, suppose total 5 class we generate, and according this 5 class, we just make this type of hello. Suppose we are just make this type of things. Suppose class and sub celebrity class we also make very low, low, moderate, high, very high. Okay, and then we calculated the weight. Okay, and how we can easily calculate the weight for each factor. So further we try to discuss about that. Suppose in this time, which is the more influence. Suppose here I can add different types of flood a factor, but which factor is more influence for flood? So it's the high weight. Okay, suppose you can put here and total weight will be 100%. Okay, suppose in this time here I put here the total
The weight of what? The weight of what?
weights
The
mainly
weight
in
of
this. Yeah,
floods or the weight of
in this time, we are applying at the GIS ASP multi-criteria analysis. Okay. So in this time, this GIS
yeah.
ASP method, we have to set the value or influence. Suppose TWI is the suppose 20% influence for flood. We select randomly. But we can also calculate it. Suppose 20% influence for the TWI. Suppose elevation is that suppose 5% influence. Suppose LULC for suppose 10% influence, but we are also calculate this type of weight. Okay, so and for calculating this weight we are using the ASP method. You can see ASP. Okay, analytical hierarchical process we are applying, and then calculate the weight for each factor. Okay, so it's another class. I will try to show you that how we can easily calculate the weight.
Weight of what?
Okay, so how I can explain it? Weight is the mainly in this time.
Hello?
Yeah.
What do
Okay.
you mean?
Yeah, I will show you that. Just a minute. You did not understand about the ASP method, I think. So I simply show you ASP method first. Suppose ASP method, I simply search. You can see ASP method is the, okay, I simply open that. So mainly ASP is the analytical hierarchy process, is one of the most popular and widely employed multi-criteria method. Multi-criteria method. In this technique, the process of the rating, okay, you can see process of rating alternatives or aggregating or to find the most relevant alternatives are integrated. Mainly in this time, using this process, we find out the weight. Okay, suppose here I find out total mainly all of those factor. I need the weight. So basically, suppose TWI and elevation or land use, land cover. Between these three factor, which factor is more influence to occur the flood? What do you think about that? Elevation, land use, land cover, or TWI? Suppose elevation is you and it depend on you. Okay, suppose you can consider it from your own side. Suppose you remember that for that, suppose elevation is the more influence for the flood. So you can just put here the high value, suppose 80% influence, and TWI suppose 10%, and LULC suppose 10%. Okay, when I consider only for the three factor, and 80% is the more influence, so that's why your result morely effective by the elevation. Okay, and it's a criteria we are using at the GIS-SP multi-criteria analysis to calculate this type of weight for each factor. Okay, so before that, we have to, first of all, we need to create this type of flood factor. Suppose TWI, elevation, land use, land cover, slope. Also, you can say other factor, mainly precipitation, drainage density, NDVI, distance from river, distance from road, soil type. We have to create all of factor. First of all, we need to create all of those factor one by one, and then make the 5 class. Okay, we make the total 5 class. Okay, and further we are find out the influence. Mainly weight is identify about the influence. What's the influence of each factor? What's the value of influence of each factor? We try to find out this factor using ASP method. Okay, so in this time, first of all, we have to know about that how we can easily create this type of factor. TWI, elevation, land use, land cover, slope. Also, you can say other factor. All of those factor need to create. Then all of those factor we are use. You can see in this time, in this follow chart, you can see. So in this time, you can see all of those factor. ASP, analytical hierarchical process, main weight, and we also set the weight. Suppose you can see this factor they put at the 0.01, this factor 0.093. So in this time, we also calculate this type of weight after creating this type of factor. Okay, and then we are put calculate this type of weight, and further we are just calculate this type of things: very poor, then moderate, high, very good. This type of region we can easily find out, and it's also very useful for not only for the flood mapping. Also, suppose you want to identify agriculture production area or anything, or anything about the decision making process, or we are using at the multi criteria analysis. ASP, GIS SP is the best for that. Okay, so in this time, our first task is that we have to create the factor, this type of factor: TWI, elevation, land use, land cover, slope. Also, you can see the precipitation. So all of those factors we have to create, and then we are just apply the ASP method. Okay. So now let's check about the one project I already done in here. So here you can see it's the one kind of map I already added in here. So basically, it's our final project. It show the this type of things: flood hazard score. So basically, in this time, it show about that process. You can see, we already create all of those factor here, all of those factor for flood. So flood hazard score. So in this time, after doing the ASP method, we can find out this type of value. So here you can see this red color identify about that mainly very high risks for the flood, and this type of yellow color identify about that mainly high. Then green is the medium, okay. Then it's the low and very low. And in this region, we are just get only for that high, medium, and very high region. Okay, basically it's the flood prone area. Basically, there are a lot of river. We can easily get this type of things. And after all, we are also calculated the area. Suppose how much area we can get for this flood, we can easily calculate the also area. Suppose high, how much area, medium, how much area, low, how much area. You can calculate the area also about that. How much area for that low, how much area for that your very low, how much area for that medium. We can easily calculate this type of things and download the CSV file also from here. Suppose download it and open. So now you can see it show about that this type of value. We can get the high, this type of area, medium, this type of area, low and very low. We can get this type of area. So basically, this is the process. In this time, we have to learn about that how we can easily create this type of layer. First of all, here you can see I show you the all of this layer one by one. Okay, so first of all, here you can see it show the one layer about the water. You can see in this time this layer show about the water for my
So
study
you
area.
will select how first of all how you select the area for studying.
Okay, for doing these things, first of all, you have to import your study area. Suppose here you can see. So basically, here I already import my boundary shape file. So this is my boundary shape file. Here I already imported.
Okay.
It's the total all of the 64 district. Okay, so this is my study area. From here, how I can upload. Okay, so simply click on the new option, new button, and go to the shape file. Okay, and further you are just select your
Yeah, I
study.
mean,
Yeah.
to begin, we say okay. The beginning is like this. Maybe share with you a shape file by email. So maybe normally we can go with my example, just my shape file that I share with you.
Okay, that will be okay.
Is
Just a minute.
and then it will be easy for me to understand
Okay, oh,
step
kind of
by
thing.
step.
Okay. Okay. So first
Mm.
of all, you have to import your shape file. Okay. So I already
I
download
mean,
your.
okay. First of all, I need to have to have this code Google Heads, like code Google Heads, and then
Okay. So this is your file you send. Okay. So this is the file. Okay. So in this time, okay. So I already opened this. Suppose it's your study area. Okay. Okay. Suppose I just open a area. So I just rename it. Suppose I just one shape file I rename. Okay. So you can see this is your study area. Okay. And now I want to use this study area and try to apply this type of things and then try to find out about that flood subscriptivity mapping. Okay, so first of all I need to import this shape file in my Google Earth Engine platform. So I simply
If
copy.
you can take the I mean the shape file with admin two. I don't know if you, yeah, admin one or two. I don't know. Is it possible or the shape file with admin one or admin two?
Okay, it's one. Okay, so let me open other
Is it
shape
this
file.
one? Because
You can see it's another shape file. If you want, you
yeah,
can also upload this shape file, no problem. And then we can get all of
yeah,
those
upload the
district boundary.
yeah uploads maybe this one. I don't know. No problem. Just to take this one with it.
Okay, so in this time we take this
The,
one. Okay, so in this time here you can see you can put this type of name. Okay, so basically we need that four file SSP. We need the SSX. We need the PRJ. But you mix all of the shape file added together and DBF. Yeah. So admin one, you can see we need only for the four files. So in this time, I just simply cart and then paste, create a new folder. In this folder, I just simply put this for file. Suppose RY, I just paste here. Okay, so that I can easily find out. And in this time, you are also put the very long name. Yeah. So in this time, I simply short name about this file. Suppose I rename it as a short name, such as suppose I put this name is the boundary, or you can put anything. Suppose I put this name is the boundary, this DBF boundary, and also put at the PRJ. So I put this boundary, then SSP, also put here boundary, and SSX, put here boundary. Okay, just same name, all of this file. Okay,
or let's say
yeah,
if you, I don't know if I can share with you if you can work about if I can share with you the Africa boundary. I don't know what is it. What's better, but Africa boundary or this one? It will be bigger or small. The Africa boundary. What do you think? If we can work
yeah, no problem. We
with
can also easily extract
Africa
the specific
boundary,
boundary or city, no problem from here. So basically, in this time here, you can see the shape file or attribute table. Here you can see in this attribute table
can
all
I
of
share with you? Can I share with you? Can I share with you Africa boundary?
any boundary you can apply. Same process. You try again, no problem. Okay, so I will show you the example in this time only for the one boundary. You try to apply the same
Okay,
things.
okay,
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 so you also get the recorded video class
okay,
also. You try to follow that. It also better. Okay, so in this time I want to work with this boundary and any
no,
specific cities or boundary I take and then further apply this code. Okay, so let's check. Okay, so let me check. Yeah, so this is our boundary. Okay, so this is my folder. Okay, so it's my local storage. Okay, so now I want to import these things in my Google Earth Engine. So click on the asset tab and go to the
yeah.
new and click on the shape
I don't know
file.
if you, I don't know if you are. I don't know if you are. Please, are you recording this meeting? Oh,
Yeah, it's
because
also
yesterday I didn't receive the file. Yeah,
okay. I
I
send you, no
didn't
problem.
receive the file
Okay,
for yesterday.
it's recorded, no
Okay,
problem. I'll send you, no problem. Previous class is also available
okay,
for the
okay,
recorded, no
okay,
problem. I send you.
okay.
Okay, so now further I simply select SS, PRJ, DPF. So mainly this four file I simply select. Okay, and then open it. You can see it through the boundary. Suppose, or I simply put the boundary. Suppose plant. For I can easily find out this name, or you can put any name, no
Mhm.
problem, and then upload.
Yeah, yeah, yeah.
So now you can see task table will be running. It will be start to the uploading this boundary. You can see it is starting the uploading. Okay, it working. You can see all of those cities boundary which are included in the shape file, all of those pool boundary, all of those is imported in the Google Earth Engine platform now working.
Okay.
Okay, you can see it done. Okay, you can see it done. Okay, so you can simply click on the refresh after completing these things. Click on refresh. Okay, and then find out the name, mainly boundary flood. You try to find out this name. Suppose here you can see the name. You can see boundary flood. So click on here, and here you can see the full shape file. And here you can see the attribute table. Okay, so basically it's a attribute table, and I think it's a mainly the different types of cities name or your administrative boundary. Okay? So different types of area, the administrative boundary you can get from here. So now import that. So click the import. So here you can see when I click on the import, it will be imported, and it show the default name is the table. Okay, I put this name, suppose RY. Okay, so now I want to visualize this study area. So map dot add layer. I want to add a layer of this study area RY, and then click to the run in this team. You can see one layer will be added, but it's not a show the focus the center of this shape file. So we simply use a function map dot center object. Object is mainly RY, and put here the 10 and click to run. So now it focuses the center of this boundary shape file. You can see we can easily visualize. You can see it show the all of those boundary. Okay, loaded. In this time, suppose I want to work for the specific boundaries from here. Suppose I want to work for this boundary. Okay, so first of all, I need to find out this boundary name. Okay, so what's the boundary name? I don't know what's the boundary name. So for doing these things, you can easily find out this boundary name from this ArcMap software. Suppose this is your boundary. I want to work for this boundary. So you can simply click on here and click on here. So now you can see here it show this boundary name is that Republic Democratic DU Congo LA. So this is the boundary name. Okay, so take polygon. Or if you want, you can simply just click on the lasso tool. Suppose click on here, select by lasso, just click. So I want to work with this boundary. Okay, so in this time in Google Earth Engine platform, I just select only for this boundary and then work with that. Okay, so how I can do that? So for doing these things, first of all, I need to find out this name, and I just simply open this attribute table. You can see it show the name about this attribute table, and here you can see the name is that this is the name about that, and in this column admin fr, this column, this is the name about these cities. Okay, so now I want to work with that. So just I simply open in here this attribute table. You can see find out the same column from the feature. We can get the same column of this name. So click on the feature. You can see this name is that, yeah, so admin f. So simply copy this name. Okay, and then just take a variable. Suppose your boundary, you can put any name. I put the boundary and call this ROI. This ROI simply filter. So use the filter function. Then put the Earth Engine filter equal. EQ means equal. What's equal? What? Simply put your column name and then put your city name. In this time you can see this city, this is the name about the cities. Okay, so for that you can simply copy, suppose just simply copy this name, or if you want you can simply suppose click on the identify and click on here. So now you can simply copy from here, simply copy. Okay, so now further I just simply go to the code editor and then paste. You can see it will be copy in here. Okay, so basically this time it's a very big name, so that's why I just simply copy the same name. Okay, so in this time this ROI, mainly this ROI is stored your full boundary, all of those district. Okay, from here I just simply select my specific district specific boundary, only this boundary, and store it in this variable boundary. Okay, so now I want to add the layer about this boundary. So use here map dot add layer about this boundary. Simply copy and paste here. Click the run. So in this time you can see we are get the another layer, two layer added in here. So one layer is all of those district and another layer is only for the one district boundary. It show.
Why you cannot, because why you cannot use all the country, because we can have the floods in each district, or
Yeah.
so that's why we cannot work in all the countries, so that we can have the overview for all countries.
Okay, so in
In
this time, if you want, you can also work for the all of those full
the
boundary, no
all
problem. Suppose you want to work for the full
countries.
boundary, all of those district, no problem. Okay, so but sometime, suppose you need for that only for the specific
It's
boundary,
better,
then you can filter it.
instead 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 to select, yes.
Okay, can you hear me?
Mm,
Cannot hear you.
okay.
Hello.
So I, I, I
Okay, your
can hear
voice
you.
is breaking.
I can hear you.
Your voice is breaking sometime.
Okay, sorry. Sorry. So, I mean, now you can hear me well, right? Now you can hear me?
Yeah, I can hear you. Yeah, yeah. Please continue. Yeah.
Uh,
Hello.
okay. So, I mean, maybe we can, maybe the full shape file, and
Yes, no problem. You can also use the full shape file, no problem. Okay. So I remove
then,
that. It's not it.
yes.
Okay. So in this time we are consider the full boundary. Okay. And then find out the flood risks for the full boundary. Okay. Okay.
You can hear
Yeah, I can hear you. I can hear you. I can hear you.
me?
I can hear you. Yes.
You don't, you can,
It's some networking issue, I think.
you
Can
can
hear.
work
Yeah, but your voice is breaking sometime.
in the full boundary, and
Yes, yes.
then we will work. We will, I mean, maybe try to do like this.
Okay, so can you hear me?
Okay. Now you can hear me well.
Yeah, I can hear you well. Yeah. Okay, it's better. Yeah. Okay.
Okay, I say like this: we can work in the all boundary, and then we will work in the specific boundary
Oh, no
to
problem.
filter the
No problem.
specific
No
boundary.
problem. We
But
can do
for
it.
now,
Yeah. No.
yes, for now it's better to work for all, and then let's just say this is to work with all. And if you want to select the specific boundary, you will do like this.
Okay, no problem. No problem. Suppose we are just working for the full boundary, and after doing that, we are just simply select for the specific boundary. Then we can get the result only for this specific
Yeah,
boundary. Okay, no problem. It will so okay. No problem.
specific. Okay.
Okay. Okay. So in this time, after doing these things, I need to import some data set. Okay. I need the DEM data. Okay. So I can simply search here. Suppose NASA SRTM. It's a mainly DEM data I can see. So basically, it's a NASA SRTM DEM data. This data set provide you the digital elevation data. Okay. We can easily get the elevation data using this DEM data. So just I simply import. I need this data. So I put this name. Suppose SRTM. You can put any name. I put the SRTM, and I need the another data set. Mainly, it's the global surface water. Needed the global surface water data set. So I simply search here GSW. Mainly, you can see global surface
Is it
water.
a satellite?
Yeah,
Is it
just
the name of satellites?
so basically, yeah. So basically, you can simply click on here. You can see basically this data set contains the map of location and temporal distribution of surface water from
Yeah, is it
1984 to
is it is it a satellite, or is it just a data repository?
it's a data repository. You can see this dataset provider is that
Okay.
this is the dataset provider. So basically, it's a global surface water app post. It's a virtual time machine that maps the location, temporal distribution of the water surface we can get from past 3.8 decades and provide the statistic on that. Change the support better informs the water management decision making. Okay, so basically, it's one kind of data provider. They are also provide the surface water for the whole world or globally we can get from here. Okay, and in this time we are just use this data set and further we are also work and there use the different types of satellite image to making this type of data set. So in this time we are just easily use this data set from here. You can see they are easily provide the different types of information for the surface global surface water. We can easily access the information and very fast information you can easily access from here from 1984 we can easily get from here. So I import this dataset also and I put this name. Suppose I put this name is that GSW. You can put any name. I put the global surface water GSW short name. I need the another
Mhm.
image. I need the another Landsat image.
So
Okay,
what about
because
SRTM?
so basically it's a variable name. It's a DEM data set. It's a satellite DEM data. Okay, NASA SRTM
Is
data
it a
set.
satellite?
Yeah, satellite.
Is
It
it a
provides the
satellite
elevation information. Elevation. So mainly where the
elevation?
high and low elevation, we also provide the global
Okay.
your NASA SRTM data set. Digital elevation we can
Okay.
easily get for the global data set. Okay.
Okay.
Basically, this data set we also need for
Okay.
making the DEM data or slope map. This data we are use for that. Okay. So now you input the
Okay.
SRTM and global surface water. Yeah,
And the last one, yeah, the what?
it's
ROI,
your
yeah.
boundary. It's your boundary. You can see this is a shape file
Ah,
which I
the
imported.
one, yeah, by Shopify.
Yeah,
Okay.
yeah, shape file.
Okay. Okay.
So I import that, and then RY. So it's this code at the layer. You can see it's at the layer about your boundary, full boundary, and map dot center object.
Mhm.
Mainly, it's focus the center view of your shape file. Center view of your shape file. Okay. So now I need the another data set, mainly Landsat. So I simply search here Landsat. It's a satellite imagery, Landsat satellite imagery. You can also get from here easily. Suppose I put the Landsat 8. Or if you simply click on the browse data catalog, you can see browse data catalog. Click on here, then click on the Landsat. Then we can easily get the all of those Landsat image collection. Okay. So from here, I want to work for suppose Landsat 8. So simply click the Landsat 8 because this type of data we need for creating the this type of factor, because our main target is that we need to create this type of factor. You can see we need to get the TWI, elevation, land use, land cover, slope. And when you want to create this type of factor, I need this type of data. I need the Landsat image. I need the DEM data. I need the global surface water data. Okay. So further, I import this type of data. So from here, I simply imported that surface reflectance, or it's the top of it, so you can also use, no problem. And then I simply copy this image collection ID and paste on my code editor, and then give a variable name. Suppose I put this name is that, suppose L8 equal to any name. I put the L8. So in this time here you can see I import all of those data which I need. I need the DEM data. I need the global surface water data. I need the Landsat image. Okay. So now I want to
Okay.
make the
What
map.
about the add layer? The add layer, it means we want to add our layer.
Yeah, I want to add the layer in here.
Yeah.
Yeah.
Okay.
And map dot
So
center
the
object,
center.
it's a focus view. View the focus on the center of this boundary.
Okay. Okay.
Okay. And in this time L8, basically it's the L8. This L8 is stored my full image collection of Landsat 8. Okay,
Okay.
this it's a unique ID about the Landsat 8 image collection. Okay.
Okay.
So now after doing these things, I want to make the map. Suppose I want to need the water. Suppose
So
water
why
data.
this land set? Because we would like to study. It is the kind of images that we want to work on it.
In this
Like
time, we need use the Landsat image for make this type of things. We can see we need to calculate the
okay,
NDVI. Okay. So for
okay,
that, we are using the Landsat image collection. Mainly, we need to use the band near infrared and red divided by near plus red. For NDVI
so
calculation, we are using
if
the
it like
Landsat.
this, it's better maybe to add a comment to say if you want to have the NDV, please
Okay, okay, okay. I
select
understand. Yeah, yeah, yeah.
the
So in
please
this time,
yeah,
it's the we
yeah,
use for the
yeah,
NDVI, and also we are used for
yeah,
that
yeah, just
LULC.
comment.
Okay, suppose NDVI and also need the LULC, because here you can see in this factor we also need to calculate the LULC also. Okay, so this
Yeah.
LULC we are also generate from Landsat. Okay, so NDVI LULC, and this GSW mainly we can get from here the water data. Suppose surface water. Suppose in this time for your study area, I need the water, where I can find out the water body. So in this time, water data I want to get from the GSW. Okay. So I take a variable and put the variable name, suppose water equal. I simply call this GSW because it stored the full data set. Okay. And then use a select function, select, and select a band. You can see this data set mainly have a band. So I simply go to this global surface water, this data set again, CSW. So click on here. Here you can see this data set have a band. Here you can see one band is the occurrence. Basically, the frequency with which water was present. Okay. So basically, this band, it's the frequency with which water was present. Okay. So I simply copy the occurrence, simply copy, and then paste here. Okay, occurrence. Basically, it's a band. This band stored the information which water was present. Okay, so occurrence. I put the occurrence, and then it's clip with my study area. So I just simply use here the clip with my shapefile. My shapefile is the ROI. Okay, so just use here the ROI. So now I just simply show the layer about the water layer. So use here map dot add layer, and call the water. Okay, and then I simply put here the visualization. So just use here the mean. Suppose 0, max is that 100. And where I can get the 0 and 100? We can get it from our data set. You can see in the band, they're already, sorry, it's not, it's a DEM data. It's a global surface water data. You can see this data set already provide the frequency mean and max. Mean is the 0, max is the 100. And it's the frequency with which water was present for your study area. So I clip with your study area, use the clip function, and this is the ROI. Mainly it's ROI stored in your boundary shape file. Okay. So put at the mean and max 0 and 100, and then put the plated. Mainly it's the color plated. So I make the color plated. Suppose I put the color, this type of color, suppose white. Then suppose put here the cyan color and put here the suppose blue color. So now further, I just click to the run. In this time, you can see it display the water for your study area. So now let's check. Okay, in this time you can see it visualize the water body on your study area. It's create the another layer. So I simply uncheck. You can see it show the water body. Okay, it's the water body for your study area, your boundary. In this boundary, we can get it's a water body. We can get the water body. We can get the water body, and water body is a more influence to the flood. Suppose it's a river. So when it's the over precipitation, easily flood. Okay. Suppose this water body, you can see water body, water body. So this type of water body is the more influence to occur of the flood. You can see water body. You can get the water body. Okay. So in this time, we can get the water data for your study area. This place I can get water. This place I can get the water. Okay. Also, you can see this place we can get this river. So this type of things is the more influence to your flood. Okay. So you can get the water. And now from here, we have to find out the permanent water. Okay. Suppose in this time, all time we did not get this type of water. Permanent. Suppose in the rainy season, water will be increased. Okay. And dry season, water will be decreased. So in this time, we have to find out some permanent water body for your study area. So now how I can get it for the permanent water body. So for doing these things, I just simply click on the inspector tab and click on the water body. Suppose I click on this water body. Here you can see it show the occurrence is the 100. I click on here, you can see it show the occurrence is the 99% frequency, 99% frequency of water. Suppose click on here, I can get that 99% frequency of the water. So just click on here, 74%. So click on here, we can get the 99%. So almost water is near to your 74%. Oh, sorry, 99% to 100. In some water we can get in here. Suppose click on here, you can get the some water is the, you can see 10% occurrence, 10%. We can get the some water from here 73%. So in this time, for the permanent water, we consider, so just take the variable. Suppose I find out the permanent water. Permanent water. So just take a variable. Suppose I put the variable name is the permanent. And now I call this water. Simply copy this variable. From here, I get only for this water, which is the greater than, suppose greater than 90. Okay, 90 frequency. All of those greater than 90 frequency I consider as a permanent water. Suppose because in this time you can see it's the river water. River water we can get almost up to 99% or 100%, 99%. So river water is a permanent water. So in this time we consider all of those water frequency greater than 90 as a permanent water. Okay, so now I want to display this permanent water body result. So for doing this, just simply take a variable. I want to show the layer. Suppose take a variable map dot add layer and call
So,
this layer. Yeah.
so why we have 90
In
instead
this,
of
yeah,
100?
in this time, here you can see when I click on here, it's a river. Okay. So click the river. I can get almost this permanent water is the 90, 99, 99. Okay. Suppose I
Okay.
click on here, I can get this pixel value for that 100. Also click on
Mhm.
here, I can get this 100. Also you can click on here, I can get this 100. So basically when I can get the 100, it's identify about the permanent water, or 99% it's identify about the permanent water, because this frequency is up to 100%. You can see 100% frequency I can get for the 99. So it's a permanent water. So in this time, from this study area, I want to find out some permanent water body. When I put here the 90, then this variable stored all of those greater than 90, all of those frequency greater than 90, and store it in this variable permanent. So in this time, when I put at the 90, then I can get the permanent water. And less than 90, it's not a permanent water. Suppose which frequency 74 or 10 or 20, it's not a permanent water. So it's a water when the rainy season will become, then this water. But when I get the greater than 90%, then it show the permanent water. Or if you want, you can also put it the 80%, no problem. Suppose greater than 80%, all of those frequency we consider as a permanent water body. And less than 80%, all of this water is not a permanent water. Okay, it's a, suppose rainy
So
season. Yeah,
this is depends to one who design the code,
yes,
or because when you say, I can, even me, I can say, okay, it's a 70.
yeah.
So someone can say, no, it's not 70, it's not, it should be 60. So there is a, I don't know if there is.
It's not a fixed. It's not a fixed. Okay, you can simply check your value. You can see it's a permanent water body. So here we can get the 100%. So in this time we are just consider a thresholding value. Suppose all of those 80% frequency we consider as a permanent water body, and then I
But
show
the
this
problem
result.
is,
Yeah,
yeah, I understand. But the problem is, when you see here, you see the occurrence is 99. 99, like this is the permanent. I don't know. I don't understand exactly when you say the permanent. What's a border? It means what exactly? Because when you click here, you can see the 99, the 99, like the high level. So the permanence, it means what? Because when you click, we don't see this 80, 80, 80, 80. We see
you
the
can see we can
90,
get
the
the less than
99.
90. We can also get from where you can see 50%. Okay, 50 occurrence
Yeah.
50. So in this time, this 50 is not the permanent water body. Suppose for the rainy
So
season, it will be
to know
stored.
that's the permanent body, how we can know that this is the permanent body? Because we have a lot of occurrence, number of occurrence. So how we can know that this is a permanent body exactly?
Okay, so for that you can see here this map data again. So basically, we can get the frequency with which water was present. Okay, when I
Yeah.
can get the high frequency, then it means that it's a permanent water. Okay, so when I can get the low frequency, it means that it's not a permanent water. And in this
Yeah.
time, this thresholding value is different. Suppose some region for the river. So river,
Yeah.
some river is all time water. Okay, so there is we can all time we can get the 100% frequency. Okay, some place, suppose in this time I can find out this type of place. You can see in the lake, in this lake is not same all time. At the same water we cannot find out. Here you can see in the lake we can get the some place is for the 100% or 90%, and some place we can get the 74%. Suppose you can see when I click on here, I can get the 98%. But when I click on here, you can see it show the result for the 49%. Okay, so in this time, this place, suppose this place all time water, it's a permanent water, but this place,
Okay.
this side of the place is not a permanent water. Suppose when I click on
Okay.
here, you can see it show about the low value 46, but when I click on this here, it show the value for that 99%.
Nine.
So in this time,
Okay.
this value, this region, all time water, it's a permanent water body, but this region is not the permanent. Sometime water is available, but not all time. Okay, you can,
Okay.
so that's why this occurrence is that low. We can get the 49%. So in this time, I take only for the permanent water body and remove all of those non-permanent water body. So for that, in this time, I consider all of those 80% occurrence, all of those greater than 80% occurrence, I consider as a permanent water body. Then this type of water body is not calculated. So that's why I call the water, from here I can take the greater than 80%
Okay.
occurrence.
So it means in the permanence body when we have this 80,
Yeah.
80, it means it's a permanence body. So
Yes.
maybe we can change to say if we have a 70.
No problem. Then we are also get the
Okay.
all of those, suppose all of those greater than 70 occurrence we consider as a permanent water.
Okay.
But it also better to use the 80 or 90. It's better to use because you can
Okay.
see all time we can get the permanent what is a 96, mainly up to
Okay.
90. We can get the all time up to 90. You can see 99. Sometimes we get the 100%. Or you can see 97. So all time,
So if we
yeah,
say 80, it means from 80 to 100,
is
it's
the permanent
it
water
will
body.
be permanent. Okay.
Yes, yes, yes.
So as it means that for in this case it will start from 80
Yeah.
to 100 to 100.
Yes, yes, yes. I mean,
Okay.
80 greater than
I understand.
81, 82, 84 up to 100.
So
Okay.
when you have the var, when you declare the variable permanent
Yeah. So now I want
equal
to show it. Suppose copy the
water
permanent
dots.
and display this result only for the permanent water body. Now you can see what happen. You can get. So in this time, I just simply put here the permanent and then use a function self max. Okay. And then basically in this time I use the self marks. In this time, it automatically marks this area, automatically marks. So that's why the self marks. And then I want to add the color. Suppose plated, so put here the blue. Okay, I show the permanent water body as a blue color. And now click the run. In this time you can see what happened. So you can see it all below it the another layer. And in this layer we are also get the permanent water body, which is greater than 80 occurrence. It loaded. Okay, it loaded. Yeah. Suppose in this time I simply zoom this area again. Suppose I zoom this lake. In this time we can see in this lake, uh, in this time we can see it's a it's a permanent water. Okay, so this water is not changed, and you can see it's a full water. Okay, in this time and in this time you can see it's a permanent water. So just I open it. It's a permanent water. Okay, so this region all time, this region have all time water, but some region can be dry or sometime. Okay, you can see it is a full water. From the full water I just take greater than 80% occurrence, so I can get this type of region. It is 80% occurrence, greater than 80%.
Okay.
So this type of region all time water, and it considered as a permanent water. You can see this region is it's a permanent water. Okay, but
Okay.
when you can see I just open the all of water, you can see it show this type of region. Okay, it's not the it's a less than 80%, less than 80%
Yes,
occurrence,
yeah.
this type of region. So it's not the
Yeah.
permanent. We can get the permanent is the greater than 80%. So you can find out the permanent water body because it also need for that the flooding. Suppose when there is a permanent water body is okay, but when the water is the overflow, okay, suppose when the water is the overflow, then occur the flood. So permanent water body there is no problem, but when the water is the overflow, then it will be occur the flood. Okay, so this is the further we also need the permanent water body. And now you can see this is the map for your study area. It show the permanent water body. It's a permanent water body. It's a permanent water body. It's a permanent water body. Mainly it's a river, so it's a permanent water body. We can create the permanent water body map. Okay, and this layer mainly it's create for the all of water. Okay, which is not
Okay.
permanent. All of those water considered in this time. So in this time, it also better
But
to use.
we can rename the layer instead to
Yeah,
say layer
yeah,
three,
yeah.
layer two.
Suppose I rename it, it also better. Then we can easily get the. Suppose first of all we add the total 3 layer. So first of all you can see map.add layer. Yeah, map.add layer. So I want to put this layer name. Suppose is a RY, region of interest, and then I put this layer name. Suppose water,
Okay.
and put this layer name permanent water. So just put here that.
Um,
Then we can easily get this things. So permanent water. So now click on this time you can see it added the layer name, and from this layer we can easily you can see permanent water RY. So RY mainly your boundary.
so when you run after click the thing,
Yeah,
you are click out.
click on here or shortcut key control and enter on your keyboard. Control and enter.
Okay.
Then it will be done. You can see it will create for your study area. We can get the permanent water.
Permanent.
We can get the all of water. We can get the study area.
Okay.
Okay. So now, okay, I think we also need the some other time also to because it is a very long code. So I want to write the one by one for your understanding. So that's why we
You
also
just a copy.
takes
You can maybe copy and paste, and then you explain line by line like this because it's better to understand line by line. If you
yeah,
when you want to change, you will
yes,
understand what's the line. Yeah.
yes. Okay, so in this time we can get this water look like this water we can get. Okay. After that, we create from distance from water. Okay. Suppose in this time, what is the distance from water? It's very important for the flood. Suppose I need to create distance from water map. In this time here you can see it's a water. It's a water. I want to measure distance from water. What's suppose this region is near to the water. You can see suppose this region is near to the water. This region, suppose this region you can see it's the far from water. Okay, and now this region is high susceptibility for flood because it's near to the water. Okay, and this region, suppose this region is far from water, so that's why this region is low susceptibility for flood. Okay, so in this time we calculate distance from water, and then we also calculate distance from the road. So for that we also need to import the road shape file also we need. So in this time we already make the water. So this is our permanent water, and we calculate distance from water area. Suppose this region is more susceptibility or high susceptibility because it's near to the water, and this region suppose it's the far from the water, so it's the low susceptibility for the flood. Okay, so now how I can do that? So just I simply write the code distance from water. Okay, so for distance from water, first of all I take a variable, simply call the distance, and I want to generate this distance from water from my permanent water. Okay, I want to consider the permanent water body. So simply copy the permanent and paste here. Okay, and then further, I just simply use the function. You can simply search the function also in here in the docs tab. I use the function fast distance transform. Get this function you can see. So basically, we are use this function fast distance transform. This function we are use to create the distance from road, distance from river, distance from water. So these type of things when I create, Then we are using this first distance transform, this function. You can see it returned the distance as determined by the specific distance metric to the nearest non-zero value pixel in the input. The output contains the values for all pixels within the given neighborhood size, regardless of the input marks. So in this time, I want to use it first distance transform, this function, and then calculate. So just simply copy these things, simply copy this function, and then paste here. Okay, first distance transform, I want to use this function, create the distance from water map. Okay, so now I simply put this distance, first distance transform, and now I want to divide with this scale. So in this time here you can see I want to check about the what is the scale about this data set. Click on here. Here is a 30 meter. Okay, so this resolution is a 30 meter. So just I simply divide with 30 meter. So put here the divide function, divide with 30 meter, and further clip with my study area. So just use here the clip function with my study area, mainly RY. Okay, RY is your study area. So after doing
Please,
these things, I
please,
need, yeah,
this
please.
this this 30 divided by 30,
It's a
30
scale,
for what? I don't.
pixel area. Mainly this data set, you can see this data set resolution or pixel area is the 30 meter. Okay, so this pixel area is 30 meter we can get.
Okay, okay,
Okay, so is the resolution.
okay,
So I simply put here the
okay.
divide with 30 meter and clip with study area. Okay, so now I want to show this
Mhm.
result. Okay,
Please,
so
could you just add a comment in this
okay,
line to say
okay, so okay, I write in
is
here.
yeah.
So it's a scale.
No, no, in the same, in the, I don't know if it is possible in the end of line. It's better in the end of line.
Okay,
Yeah.
okay, 30 meter, 30 meter is a scale of this data set. Mainly it's the global surface
Okay.
water.
Mhm.
Okay, this data set we put in here. Okay, so now add the layer about that. So just I simply use here map dot add layer and call this distance, copy and paste here. So now click the line. This time you can see it added the another layer about the distance. And then we also put the name about this layer.
Like distance.
It generate. Okay. In this time it create this type of color because I did not add any color about this distance. So for doing this, I simply click on here and then I simply click on the suppose 98% stress. So now I can get the 0.2 meter to 10 meter. Okay, this range. So now apply it. You can see what happened. In this time, I can get this type of result. Okay. So in this time, you can also add the color plated. So click on the plated option. So click on here. I want to show the color near to the river as a you can put any color. Suppose I put here the suppose blue color. Okay. Then put here the plus sign. Suppose then I put here the this type of sign color or any color you use. Then put here that suppose green color. Okay. Then suppose put here that yellow color. Okay. And then far I need red color. So red color identify about the far distance. Okay. Or you can put any color, no problem. And then apply. So in this time you can see what I can get from here. I can get this type of map. And basically it's the distance from
So
water map.
when you say the distance, it means the distance from
Distance from
what?
water.
From the deep, from dipping
the what distance from dipping or distance from the I mean from the one location to another location.
No, in this time here you can see it's a water, okay, and which is the
Yeah.
close to the water, okay, near to the water, it the low distance, okay, low distance.
Yeah, this distance. Yeah, the
Yeah,
problem of distance. I want to just to understand the distance. It's not. We are not. It means that it's not the deep. It's just the distance.
yeah,
I mean,
distance.
yeah, because
How far
sometimes I'm
distance?
confusing
Yeah,
distance, distance and the deep. If for this one is just the distance from the water and the I mean the
near
location
area, neighborhood
near
near
area,
area.
near area.
Yes, yes.
Okay.
In this time, this
Okay.
red color identify about that far area, okay, and then you can see the blue color identify about the close to the area, close to the river or close to the water. Then cyan color, then yellow color, okay. So in this time, you can see this type of region which are near to the water, it is the high susceptibility of the plant, okay, and far from
Mm.
the water, suppose this type of red color, it's the low susceptibility of the flood, because it's that far from the water. So I simply import that, and after doing this thing I simply copy after importing, and then paste here, paste here, and further I put the layer name, suppose distance from water. Okay, now click on. Then this time we create the another layer. You can see distance from water, and we also need to create the map for distance from road. Okay, so for that we need to create the road shape file, and then we are also create the distance from road. About that we need to create the drainage density of your river, so a lot of things we need to complete one by one. Okay, so we can create this type of map for the study area. Okay, so in this time, after getting this type of map distance from water, we have to generate the another map, only the distance without permanent water. Okay, only the distance without permanent water we have to create it. Okay, so I'll write this thing, suppose only the distance without permanent water. For doing these things, only the distance with the permanent water. So for doing this thing, we are just simply take a variable, suppose only distance, and then I call this distance, and then I simply use a function update max with distance and not equal to 0. Okay, not equal to 0 I put in here, and I also consider the another things, mainly I also add SRTM, basically it's a temp data with max. Okay, so now I show this result first, then try to explain about that. Suppose just take a variable map dot add layer, call this only distance without permanent water, and now click run. I have the wrong spelling in here, simply copy and use the check. Get loaded. So now further click on here, and then custom is state 98%. Then I. So in this time we can get it the distance without permanent water. And I want to add the color. Suppose same current we use in here, such as click on the plated and plate the color. Suppose for the blue color, for the near to the distance blue color, and then put here that mainly suppose this type of cyan color, and then suppose put here that suppose green color. Suppose put here that yellow color, and high distance show the red color. Okay, then apply, and now to be added in here you can okay added that these things, and further import. Okay, and then simply copy this variable name and add after this object name, and put this layer name. Mainly I put this layer name, suppose distance from distance without permanent water. Now click run. Okay, create another layer. Okay, in this time after completing these things we talk about that your data, mainly it's called the dem data. Okay, so dem data, in this time we create the elevation using this dem data. So I already import the dem data srtm, this dem data. So for doing these things just take a variable. Suppose I put the variable name is the elevation, and call this srtm. It's clip with my study area, mainly it show the result and the ROI. Okay, so now I show the dem or elevation data map dot add layer, and call this elevation and click run. So now it added the elevation. You can see at the another layer for elevation or dem data. Okay, okay, it's working. You can see we can get this type of dem data. So click on here and custom state 98%, and click the apply. So now we can get this type of dem data. You can see. So, or if you want to add the color, suppose I want to show the low elevation as a blue color, then I want to show the then greater than I use the green color, then greater than I want to show the yellow color, and high elevation I show as a red color. So put the red and further apply. So now you can get this type of red kind is the high elevation. Okay, there's the low elevation. Okay, we can easily find out. So import and then find out simply copy and paste after the layer map.add layer, paste in here. and put this layer name, suppose dim or elevation, anything you put, suppose elevation. So now okay, in this time you can see it also added the elevation layer also. Okay, you can see it's the elevation about that. You can get the elevation. Okay, so okay, so in this time after the elevation, we also need to create about the TPI, topographic index. We have to create about the TPI, topographic position index, TPI, topographic position index. We need to create the precipitation. So actually, we have to create all of those other parameter. So basically, this type of other parameter we create one by one. Okay, one by one, TWI, then elevation, LULC, slope. So all of those things we create one by one, and further uh, put the weighted, and then create these things. Okay, so basically today we are not continue in this time, so further class we also continue from here and try to discuss about the other factor. Okay, one by one we try to add and explain all of those things one by one. So next class we also try to discuss about that. In the meantime, I will send you the code link and also send you the recorded class. Okay, so for that you can easily practice on your own system, on your own computer. Okay, so you also try to practice. Okay, so I'll share this boundary. Just click on here ROI, and then just click on the share so that you can easily access this code and also get the all of those layer and also get the result. Okay. So further next class we also try to discuss from the other part about the TPI, precipitation, slope, land use, land cover. We are try to add and then try to find out the full project. Okay. So I will send you this code in the WhatsApp.
For me, the most important, maybe we'll do everything, but the most important would be the, I mean, the place with a high level and another place not low level, low
Yeah.
risk. No, I mean, we want to classify the risk of
Yes.
floods.
Yes. Yes.
This
Yes.
is the risk of floods. This location will have a high level. This location, I
Yes.
think it will be possible for that.
Okay, no problem. We try to complete the full project.
So
And
if we have already do like this, it means that the data will be updated automatically.
not yet. I need to send you the link also. So in this time, this link you can easily access, which I do for the students class. You can
Yeah,
access.
just just to know if we have all if you build your if you design like this
Yeah.
and the data, I mean the data, it will be refreshed automatically
No.
in the
Further, we have to send the new link again. Suppose click the get after edit anything. We are just put the get link again. So that's why it create the another link. So when I send this link, then you can also easily edit the other. Okay. So in the meantime, I also try to develop all of those full parameter so that
okay,
further for the next class I'll show you the code and explain one by one. It also better and
okay,
also
okay.
easily we can easily complete these things. Otherwise, for the
Mm.
writing code, it takes
Because
some time.
okay,
Okay.
because the
Okay.
most important is to know
Yeah.
is to know which location high level and
Yeah.
which location is not
Okay. No problem. Inshallah, we
the
can wait. No problem. Yeah.
the risk of
Yeah.
flood. So I would like to show you no, maybe
Yeah. Next week we try to.
next week, yeah.
In the meantime, we also try to practice and also suppose you try to use this code for other region. Okay. And then check what
If you
happened.
can give me, if you can give me just 1 minute,
Yeah.
because I'm doing maybe 2 minutes. I want to share my
Yeah. Yeah.
screen.
We can simply share. Yeah.
Yeah, to show you just something. Okay, it's just 2 minutes. So I saw this. I don't know if you see my screen.
Okay, it's opening. Yeah, opening. Yeah, opening. Yeah.
Yeah, my friend is doing some kind of exercises like this. So I get this file, but I don't know how he. When I see the shape file here,
Yeah.
then I see the shape file here. I can see that this one is Excel sheet, maybe.
Okay, so you can simply
This
close the your meetings ready. So close this. Okay, it not so close this. Your meetings ready. So close this. In this time, it not show the fully your screen.
uh
Your meetings ready. So simply click the close share and then close it. Suppose you can
let
see.
me share. Okay.
Okay, it's okay. So now share. Now share. Now share. It's okay. Now share. Now share. It's okay.
Okay. So
Yeah, yeah.
I get this ones, but if I understand, this is the Excel sheets. Maybe I think this is the Excel sheets for affected people.
Okay, so okay. So in
So
this time,
and,
uh,
and my problem now is how he used this one.
symbol
Only this one. Yeah. No, 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 sample. This one, the six,
six
seven. It's like the
twenty.
ditch. Yes, the ditch. The ditch. This one. This one
Okay,
because when I saw like this, it disappear. But when
okay,
you like this, it appear. Don't this one? I don't know how they
okay. So
this
you can simply
bubble.
click on the dates and go to the attribute table. Click
This
on here.
bubble.
Yeah, click and go to the attribute table. Cannot show the other table. Other tab is not showing.
I don't know why.
You have to share the entire skin. Then I can show all of tab.
Like this. I think it is here.
Okay, I cannot hear. I can see only QGIS, but not show the attribute table.
Oh. So how can I share also this one?
Okay, so you can simply click on the entire skin.
Print screen.
Yeah, so click the your presentation and entire skin. In this time, it only show the QGIS. Okay, so I cannot see the your attribute table or others. I cannot see.
So how can I do so that you can see?
So click on
Just
here and share now. We can click on the entire skin. You can see the entire skin, select and then share. So now stop the sharing again and try again for the click on here and then share now and your entire skin. Okay, entire skin. You can see the share. You can see the entire skin. Then select your screen and then share.
this, yeah, you can see
Yeah. So now open this attribute table. Okay. So now it's okay. Yeah. 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 So it's open. Yeah.
attributes also. Okay.
Okay.
So if I this is the the attribute table. So this one
Yeah.
is a ditch.
Okay.
This
And in
one,
this time,
yeah,
this
this one
attribute table,
20 is this
it's a
one.
point shape
Six
file. I think
is
it's a
this
point.
one. Hmm.
It's a point shape
So
file.
I don't know how he add this kind of Bible.
Okay. So for that, you can simply click on the properties. Go to the properties again. Dates. Click on the dates. Dates. And here you can see the labels. You can see the labels.
Where? Here.
Okay. So okay, find out the labels. Add the label. Not policy. You can see the equities. Yeah, yeah. Click on here. ABC. Okay. So from here, you can see here. You can see the value.
Um,
You can see that's value. The second tab. Value. VALEUR. 1, 2,
Wait.
3 dates. Yeah, in this column, click on here. Yeah, yeah. Oh, up, up.
Echantillon. This one echantillon. Here.
Yeah, Velur. Yeah, yeah. Dates. DET. Dates. You can see the 1, 2, 3 dates. Not here.
Oh,
Below that.
here.
Yeah,
Yeah.
yeah, yeah. Here, yeah, 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 yeah. Click on here. Yeah.
Like
So
this.
in this time, which value you want to show, dates affected, or which value you want to show, just simply select this column. So
Maybe let's just try with another column. Let's take this
affected.
one, maybe.
Yeah. So click the effect. Click on here. Okay. So now further, just simply click on the apply and OK. Then now it show about that uh, is affected. Okay. So simply go to the below. You can
Yeah,
check
but
the apply
how
and OK.
we can my is how this is a Bible, a Bible. That is the problem. It can show this one. If I apply like this, it will show. Yeah, it will show like this.
Yeah.
But how how it can show that it is a Bible? How can show that this is a Bible? To specify that this should be a Bible.
Bible means
Bible. This kind of I mean this one this zero, yeah, like this with the red color. I don't know if you get what I mean. The Bi- this
okay. Breaking your voice. Hello. Hello.
this Bible, how you can change. Yes, hello.
Yeah, I
How we
can.
can change this Bible? This one is a Bible. How we can say okay, this should be a Bible? How we can set up
Okay. So
this
for
kind
doing
of
this, you can
Bible
go to the
because this
style.
is
You can
all already
simply
set up.
open this tab again. Open this full screen. Yeah, full screen about the tab. Yeah, yeah. So here you can see the different types of style about that. Yeah,
This
you can see the different types of style. In the left corner, you can see the tampon, muscle, airy plan, omber, position, rendo. So in this time, it's the different types of style. Okay.
how can the, yeah, I understand, but how we can use it this Bible? Where may I find to configure this Bible, to set up this Bible, to say okay, this should be a Bible instead of this one? Where may I find it here? Because it's showing that it should be a Bible. The setup that should be a Bible. How they make, how they do this one, this Bible, this one,
Okay.
this.
And okay.
That is
So
just I want
actually,
just
I don't
to
understand
know
about your Bible.
how
What you need,
they
I am not clear about that.
okay, the Bible. Let me. I would like to do this kind of things. I want to know how they do this. How they show this zero. We have a circle. We have this. Let's say circle or what? This how they do this one. This how they show this one like this. This one. This one. How they do it. I don't know if you get what I mean.
Yeah, no, I cannot understand. Oh,
This no, this one. This red circle, this red. We
yeah, right.
in
Yeah.
English we call it the Bible. Yeah, this reds.
Okay. So what
How
you
they
do in
do
this
this
time? What
red
what
here?
what you
How
do?
they specify? How how they set up these reds? These reds here.
Yeah,
How
yeah,
can I? If I say this, if I put like this, it will disappear. If
yeah,
we come this, it will come. But how to do it? Because I know how to do this kind of this one. I know this one. I know how to do it because this one we can go to the classifier and This one is I know, but how to do this one? Because to classify this one like this, to classify this one, yeah, I know, but to do this one, I don't know.
So in this time, this data is a point. So for that we are not classified. Okay. So it's a point. If
No,
it will be
don't
polygon,
you
suppose this
don't
type of
understand.
boundary, then it will be okay for make the classification.
You don't get what I mean. It's not the problem of classification. For me, I want to change. I want to do my. But my question is very easy to understand. This one,
Yes,
how
yes.
they do this? How they add this kind of things, this kind of symbol, zero, like this kind of reds, this kind of red
Okay.
circle or reds. I don't know. Normally they call it Bible. Normally,
Okay. Without
because if
you,
you
you
go to
want
the
to remove
internet,
this background of the red. Yeah.
if you go to the internet like this, we show Bible. You will see they call it Bible. Hmm?
Hello.